Here's my hydraulic case study presentation. I'm Kyle Clark. I'm the presenter and also the creator of it. So the machine we're going to be going over is a Komatsu WA430-6 wheel loader. The serial number is A41008. It has 2,667 hours on it when this case study was done. It's owned by Contractors Rental Corporation. Which, as many of you guys know, is a sister company to AIS. Basically, it's the rental company. So our complaint is the hydraulics are overheating and not cooling down. Anything that the operator can do to try to cool it down, they just stay hot and they don't cool down at all. So we're going to jump right into our diagnostic procedure on this machine. So the tech who diagnosed it, they drove it around for a little bit and found that the hydraulics did get hot and stayed hot. So then they turned around and they checked all the pressures in the machine, and for the most part, all the pressures were fine. A couple of them were maybe a little bit low, but still in spec. They just weren't all at top of spec. So the tech found that the steering pressure was high, and the fan speed was high. So he teed in after the steering pump and before the steering valve, and found that the steering pump wasn't destroking. With the machine in neutral, no controls touched, and at wide open throttle, they found that there was about 2,800 psi or 200 kilograms per centimeter square of pressure after the pump and before the valve, which means that it's sitting at full pressure over relief, which will cause our overheating complaint because you're pushing oil through the relief valve, causing heat. And since it's not destroking, it's just going to keep pushing that oil over relief and not allow it to cool down, even though the fan is running at full speed, actually a little high on speed, a little fast. There's just no way to get all that heat out of the system when you're just constantly building it. It's like when you want to get a system up to temperature for testing, like we did with the skid steers in class. When you run all that oil through the orifice, when you crank down the variable orifice on the flow meter and it heats oil up, it's the same effect, just the machine's doing it on its own and it's not supposed to be doing that. So the cause was found through a PSN, and it's the servo piston has excessive leakage because of the piston hole on the end there. It gets worn from debris and gets too big and causes there to be excessive leakage past the servo piston, which doesn't allow it doesn't allow the piston to build enough pressure to push the pump out of swash or de-stroke the pump. So the bias spring just holds it at in swash, and so it's constantly creating flow. And you can see the small scratches in that on the slipper of that servo piston. That really has not a whole lot to do with it, other than you can see that since it has the scratches, it had debris running through it at some point, and that's what wore our hole, which caused the excessive leakage. So this is going into the servo piston a little bit, and this picture here is a cutout I took out of the PSN for the machine. So the first picture in there that has a red circle, that's the actual servo piston in the pump. You can see it's pushing on the swash plate, and the other picture with the arrow pointing towards it, that's the servo piston outside of the pump, which is, I took a picture of the end of that slipper on there. You can see the drilled hole through it, and they're explaining on here that they're going from a gas nitrocarburizing to a tough treading. hardening procedure, which brings our surface hardness to a HV 600 instead of an HV 700, which is a harder surface hardness, which will help the pump be more durable, or at least just the servo piston be more durable against debris that can get in there. Um, it's very hard to keep debris out of a hydraulic system. I mean, it's gonna happen, and that's why everything wears out. If there was no debris, then stuff wouldn't wear out, and it'd last pretty much forever, and no friction really. Um, but uh, it's just a part of it, part of everything. So I wrote down here that they changed the hardening process for the servo piston, which I just explained, and they added some screens in the pump control circuit. So that's also to try to keep some of that debris out. Even though they changed the hardness, the hardening process to change the hardness of the servo piston, they want to take some other steps to try to keep any debris from getting in there. So it makes the part more durable, and also they make the part more durable, and also they add screens in that circuit to try to keep some of that debris that caused the servo piston hole to wear out, which caused our overheat issue in the hydraulic system. So Um, here I have a picture of the actual steering and brake pump out of the machine, which is the suspect component. Um, so they followed the PSN number AA08015C for the repair of the hydraulic system. I'll have it's a 23-page correction. It includes pulling the cab off the loader and doing some pretty extensive fixes, which includes replacing both the steering and brake pump and the loader pump because they are the same exact pump internally. So they will have the same issues at some point. So they updated that with that hardening, and they also have the technician add some screens in places to keep some of the debris out of the system. Like I said before, it's impossible. Even though it is filtered, it's impossible to keep all debris out of everything. They're just trying to lower the risk of this happening again and causing much heat to build in the system, which can also cause other problems in the system. So yeah, it's a pretty big procedure. They go over it pretty well in the PSN. Um, I'm not going to put the whole PSN on here because, like I said, it's 23 pages, and but yeah, it's quite the procedure, and that's what they did, and that included replacing the pumps in the system. So, well, this is what I just kind of went over. This is the PSN. I took a quick screenshot of the reference number, and the date is actually they came out with this PSN September 26, 2008, and you'll see in the work order that this repair was completed in 2012. So this is just going back over replacing the steering and loader pumps with updated pumps, which includes that hardening process, and then adding screens for the added debris protection. So there's really not a whole lot more to this. This is a pretty easy one here to look at, and you know when they came to the conclusion in the diagnostics that the pump wasn't coming out of swash or destroking, um, it kind of led them to look at some of the PSNs and that the hydraulic system was overheating. That was also a clue in that part of this, the system. So really, what we need to learn here is, it started out as a hydraulic overheat complaint, and you can blow out your coolers and all that, but when that doesn't work, what do you do? Well, you got to look into things other than the fan and the actual cooling part of the system. You got to try to see uh, where this is these issues are occurring, and this would be a great place for a thermal imager to see where all that heat is building at in the system. Now they didn't use that back in 2012. Thermal imagers weren't really the norm, and people are still trying to get used to using those yet, and not a lot of people really seem to have them yet. But this would be a great place for that, just kind of as an extra added in there part, because that would have led them right to that the relief valve sitting over relief, and the conclusion that the pump is not destroking. So, anyways, after this, um, Steve Sutton at AIS is the one that provided me with uh, the parts and the work order and the PSN and all that so all the information I needed to complete this case study. Um, so here's our work order. You can see it was completed on 10/15/12, which is quite a while ago, but a very good specimen of what has been done, and keeping an eye out for stuff like this, because it does happen. You know Debris is the biggest enemy of the hydraulic system. So this is the PSN. I just copied, or I just screenshot the first little bit. In the description of this is you can read the piston hole portion warned from debris in the circuit which entered into the servo piston. Leaks the servo piston control oil, and the pressure is hardly able to rise. So that bias spring just pushes the swash plate on the maximum side, and um, uh, it just sits at full flow and sits over relief because it hits the relief valve when nothing is demanded. Nothing is demanding oil. So, but yeah, that's it on my case study analysis. So if you guys have any questions, just feel free to comment in the discussion board, and I will answer as much as I possibly can. Thank you.